to my YouTube channel Math Sikshak. I am a mathematics teacher with 15 years of teaching experience. I have been preparing students for CBSE, ICSE and IGCSE board examinations. During this journey, I have realized that mathematics needs to be taught in a simple and meaningful manner. It is my endeavor to present the topic step by step in a simple manner. I have tried to correlate the problems with real life situations. In this presentation, I will be introducing you to trigonometry. Trigonometry is found throughout geometry, as every straight-sided shape can be broken into as a collection of triangles. At the end of this session, you will be able to understand what is trigonometry, interpret the terms used, and apply the trigonometric ratios. My presentation is divided into four parts. This is my first section, the introduction. In this section, I will be introducing you to the various mathematical terms. I will make you realize how important is the understanding of trigonometry. In our previous classes, we have already learnt that sum of interior angles of a triangle is 180 degree. This theorem helps us to find out all the interior angles of a triangle. Next, we have learnt that sum of interior opposite angles is equal to exterior angle. With the help of this theorem, we can find a link between the interior and the exterior angles. In the chapter Inequalities, we have learnt that sum of two sides of a triangle is greater than the third side. So with this theorem, we can find a relationship with the sides. So these two theorems helps us to find a link between the various angles of the triangle, and this theorem helps us to find a link with the sides. Now, can we link the sides and the angles? Yes. Trigonometry, it is that branch of mathematics which helps us to find a relationship between the sides and the angles. The combination of sides and angles helps us to find the unknown sides and angles. Trigonometry is also closely related to other branches of mathematics, especially complex numbers. Next, let us try to understand the meaning of the word trigonometry. The word trigonometry is a Latin derivative from the Greek word for triangle. Trigonometry is all about triangles. It is trigonometry. Tri stands for three, gono stands for angles, and metry stands for measurement. So trigonometry just need not be applied to right-angled triangles. We introduce the concepts with right-angled triangles and then proceed on. Now let us understand why the learning of trigonometry is so very important. I would like to measure the height of this star. Trigonometry helps us to find the height of the tower, mountain. Not only this, it is used in navigation, oceanography, to find distances between celestial bodies, and so on. In my next section, that is the explanation section, I will be telling you how to calculate the heights and distances between two objects. First of all, let me explain to you some of the mathematical terms that we will be using in trigonometry. First, reference angle. Next, trigonometric ratios. And next, complementary angles. So I start my explanation by explaining to you the meaning of reference angle. It is the acute angle between the terminal side and the x-axis. Now what do we mean by this? An angle is formed when two rays originate from the same point, and this point is called as the vertex. In trigonometry, the vertex is the origin and one ray is placed on the x-axis. It is the positive x-axis. This is called as the initial side of the angle, while the other ray is called as the terminal side of the angle. So it is an acute angle. So its value is going to be between 0 to 90. Between the terminal side and the x-axis. So terminal side is this one, this ray, and x-axis is the initial side. So the angle between the terminal side and the initial side, it is on the positive x-axis, and the value of the angle is an acute angle. That type of angle is called as a reference angle. Now, why is reference angle important? Reference angle is important because we use it to simplify trigonometric ratios. Now, what do I mean by this? The side that is opposite to a right angle is always called as the hypotenuse side. Whereas, to find the opposite and the adjacent side, we require the reference angle, that is theta here. So for theta, this is the opposite side and this is the adjacent side. Why? The side that is just opposite to theta is called as the opposite side. So this side is just opposite to theta. It is called as the opposite side. This side is along theta, so it is called as the adjacent side. So with the help of theta, we find out the opposite and the adjacent side. Therefore, to find out the value of trigonometric ratios, we will always use the reference angle theta. Next, let us try to understand what is a trigonometric ratio. As the name suggests, it's a ratio. So we are comparing two sides, and both the sides are of the same units. So when we compare the two sides, we divide one side by the other side. So the ratio between any two sides of the triangle is called as a trigonometric ratio. Now let us understand it clearly. Cos theta. So cos theta is equal to the adjacent side by the hypotenuse side. So my reference angle is theta, and cos theta will be called as a trigonometric ratio because we find it out by dividing the adjacent side by the hypotenuse side. Both the sides will be of the same unit. So the side that is along theta is called as the adjacent side, and the side that is opposite to theta is called as the opposite side. And always the side that is opposite to the right angle is called as the hypotenuse side. The next trigonometric ratio, sine theta. Sine theta is equal to opposite side by hypotenuse side. Tan theta is equal to opposite side by adjacent side. So sine theta is opposite side by hypotenuse side. Cos theta is adjacent side by hypotenuse side. Tan theta is opposite side by adjacent side. So we can remember this as SOH, so CAH-TOA. So it's SOH-CAH-TOA. So this is one easy way to remember. SOH, Sine theta is opposite by hypotenuse. CAH, cos theta is adjacent by hypotenuse. TOA, TOA, tan theta is opposite by adjacent. These trigonometric ratios are reciprocal of our main three standard trigonometric ratios. So cosecant theta is 1 by sine theta. The reciprocal of sine theta gives you cosecant theta. The reciprocal of cos theta gives you secant theta. And reciprocal of tan theta is cot theta. Now, let us understand the meaning of complementary angles. Two angles are said to be complementary if the sum of both the angles is 90 degrees. So if theta is one angle, the other angle will be 90 minus theta. So theta and 90 minus theta are called as complementary angles. Now we link complementary angles with our trigonometric ratios. This complementary angles will be discussed in detail in my next presentation. Proceeding further, we move on to our next section, that is the solved questions. In this section, 4 examples have been solved step by step. Example 1. Find tan A if cos A is equal to 4 by 5. So we know that cos A is adjacent side by hypotenuse side. CAH-CAH. So cos A is adjacent side by hypotenuse side. The reference angle here is A. So based on the angle here, we are going to find the opposite, the adjacent side. So the side that is along it is called as adjacent side. Now cos A is 4 by 5. Does this mean that the adjacent side is 4 centimeter and hypotenuse side is 5 centimeter? No. This is a ratio. So therefore, after being reduced to simplest form, it is written as 4 by 5. So therefore, we'll write the adjacent side as 4x and the hypotenuse side as 5x. Let us consider the opposite side as y. So we are considering BC to be equal to y. Now we can apply Pythagoras Theorem as it is 90 degree at B. So Pythagoras Theorem tells us that the hypotenuse square is equal to the sum of the squares of the other two sides. Therefore 4x whole square plus y square is equal to 5x whole square. So when I simplify 4x whole square, it is 16x square plus y square is equal to 25x square. Therefore, y square is equal to 25x square minus 16x square. We are bringing 16x square to the other side. So y square is equal to 9x square. Therefore, taking root on both sides, we get y to be equal to 3x. So what is y? Y is opposite to our reference angle A. So it is on the opposite side. Tan A is equal to TOA, TOA. So that is nothing but opposite side by adjacent side. That is, so opposite to my reference angle A is BC and the side that is along the reference angle is AB. So tan A is equal to BC by AB, that is y by 4x. We have just found out the value of y is 3x. So it is 3x by 4x, that is equal to 3 by 4. Moving on to our next example. Cos A is equal to 21 by 29. Find sin A plus tan A. So similarly, We are considering a triangle ABC, right angled at B. Cos A, so my reference angle is A. Adjacent side by hypotenuse side. So my adjacent side is 21A. My hypotenuse side is 20A. Again, since it's a ratio, we cannot take this as 21 and this as 29. Right? So, AB is equal to 21A and AC is equal to 29A. We apply the Pythagoras theorem as it is a right angle triangle. It states that the hypotenuse square is equal to the sum of the squares of the other two sides. Therefore, AC square is equal to BC square plus AB square. So we need to find BC square. So we bring it to one side, and so BC square is equal to AC square minus AB square. AC square is 29A whole square minus 21A whole square. So that is equal to 841A square minus 441A square. That is equal to 400A square. So BC square is equal to 400A square. Therefore, BC will be equal to root over 400A square, that is 20A. Now we need to find Sine A. Sine A is opposite side by hypotenuse side. So the side opposite to my reference angle A is BC and the hypotenuse side is AC. So it is 20A by 29A, that is equal to 20 by 29. Similarly, tan A is equal to BC by AB, opposite side by adjacent side. So it's 20A by 21A, that is 20 by 21. Therefore, Sine A plus tan A is equal to 20 by 29 plus 20 by 21. We find the LCM, that is 609. Therefore, 20 into 21 plus 20 into 29 is equal to 1000. So it is 1000 by 609. Proceeding further to our next example. Tan A is equal to 1 by root 3. Find the value of cosecant A plus secant A. So these two ratios, that is cosecant A and secant A, are reciprocal ratios. Cosecant A is 1 by sine A. Secant A is 1 by cos A. So it is a right angle triangle, right angled at B. Tan A is opposite side by adjacent side. My reference angle is A, so the side opposite to it is BC and the side along it is AB. So that is nothing but 1k by root 3k, that is 1 by root 3. So then we apply the Pythagoras theorem again to find out our hypotenuse side. So AC square, that is the hypotenuse side whole square, is equal to the sum of the squares of the other two sides. So AC square is equal to AB square plus BC square. So AC square is equal to root 3k whole square plus 1k whole square. Root 3k whole square is 3k square plus 1k square. So AC square is equal to 4k square. AC is equal to root over 4k square. AC is equal to 2k. So now we find out the values of cosecant A, that is 1 by sine A, that is nothing but hypotenuse side by opposite side, that is AC divided by AB. We have already found out the value of AC, that is 2k divided by 1k, that is equal to 2. Secant A, it is the reciprocal ratio of cos A. So secant A is 1 by cos A. So it is hypotenuse side by adjacent side, that is AC by AB, that is equal to 2k by root 3k, that is equal to 2 by root 3. Therefore, cosecant A plus secant A is 2 plus 2 by root 3. We find the LCM, so it will be 2 root 3 plus 2 whole divided by 3. We come on to our last section, that is the unsolved sections. Questions have been given with answers. For any clarifications, you can mail us at mathshikshak@gmail.com. For any feedback or queries, please contact us at mathshikshak@gmail.com. Please subscribe the channel. Thank you for watching Math Shikshak. Kindly subscribe to my YouTube channel for further updates of my upcoming videos. Thank you.